So today we're going to continue talking about section 1.7, which is about the same thing it was about on Friday, which is inequalities. So we're going to continue to talk about inequalities.
That's a big word.
It is a big word. Lots of vowels in it. Yeah. All right. This is going to be one of those moments where I deviate from the book just a little bit, and I'm going to show you kind of how I do the problem, and so we'll get there. But I wanted to let you know that I tend to go off track a little bit from how the book does it, just how I process it a little bit differently. If you like the way the book does it and you want to kind of explore that method, you can. I'm never mad if you're using different methods. So make sure you know that you can do that, but I'm going to show you, like I told you guys, I'm an only child. I'm going to show you my way because it's my favorite way, right? Or I wouldn't do it this way. All right, so here are some steps. You can come back and revisit these. We're going to hop into a problem because I think that's the best way to learn it. Sometimes it's great to talk about it and front load the conversation. Sometimes it's just better to hop into a problem and experience it and do the things, and that's what I'm going to do. Here we go. So this is problem number 1. We've got 3 of these that we're going to do total if you kind of want to think about where are we headed today. We've got 3 example problems total, but they do take a minute. Gross. Okay. We've got inequalities still, but instead of inequalities that are linear or absolute values, now we have quadratic inequalities.
Who are you reading at?
Come on.
My mom?
Literally your mom.
Can I climb up?
No, you can't go see your mom.
She loves me so much. You can't not see
Okay, here we go.
Just go. I think that makes sense.
All right. Here we go. It's all in the video too. Perfect. All right, here we go. Step 1. We want all the terms to be on one side of the equation so that we can solve. So I'm going to go ahead and subtract this over and add this over at the same time. If you are somebody who likes to do things one at a time, because you get thrown if you do too much, you can do this in multiple steps. But again, I'm going to just move it at once. Yes. I don't even care if you know that it's step 1, but it does match up to step 1 up here, where we're moving all the terms to one side. So we've got x squared minus 5x plus 6 is less than or equal to 0. 0 because everything went away from that side. So yes, that is truly step 1 because it matches with move all the terms. Okay, so this matches with this. Next, we want to factor and solve. Could you use quadratic formula or complete the square if you would rather?
Probably.
Yes. Okay, but we're going to use factor and solve. So this step 2 literally goes with this step 2. Now, do you have to actually do this out in steps and show me that you know which step is which? No. I just want to make sure you understand kind of what they're saying, and that's why I'm connecting the dots right now. Okay, so step 2. 2 sets of parentheses. X times x is x squared. Okay, careful. What do we need?
No, you need 2 negatives.
2 negatives, because we need to multiply to a positive. Negative 3 and negative 2. Okay. Next. We are going to find, I call them critical values. So the critical values are the values that would make it 0. So the critical values here would be positive 3 and positive 2. So those are my critical values, positive 3 and positive 2. You can just say CVs for short. So I'm going to come down here to step 3, which is my number line, and I'm going to position those on my number line. So I've got the number 2 and I've got the number 3 which just so happens to be right next to each other. They're not always right next to each other. Sometimes they are, sometimes they aren't. Do you see how 2 and 3 have divvied this into 3 sections? I have a section in my graph here, I have a section in the middle, and I have a chunk over here. Yes?
Yep.
Okay. Alright, so for intervals, I'm going to think about this interval first. I can go from negative infinity all the way up to 2. Now, I can include 2. Do you see how with my signs it's less than or equal to? So this is going to mimic that it can be equal to. If it had just been less than, then I'd have a parenthesis here. But because it's less than or equal to, I'm going to put in that bracket. Alright, I'm going to go 2 to 3 is my chunk in the middle. And then I'm going to go 3 all the way up to positive infinity. And remember, stuff that we can't like reach out and grab and touch, we put a parenthesis. So I can't reach and touch the number infinity, like it's not a thing, right? So I'm going to leave that as a parenthesis.
Does it have to be in that form? If you do like x is less than
If you wrote it in a different notation, that'd be fine. I would prefer it in this form, and I think we're just going to keep using this so much that I think eventually you'll prefer it too once you get more comfortable with it, if that makes sense. Okay, I don't write sign of. I do something where I call it trial value. So again, I do it my own special way. So that says trial values. It looks like an O, but it's a U. And then down here, I say true or false. So I do things just a little bit differently than your book. Not like significantly differently, but just a little bit. Okay. All right. We're going to play pick a number. It doesn't matter what number you pick, and you don't have to match me. You're going to pick a number that lives in this interval. So I'm going to pick 0, because 0 is an easy number to plug in. And that's what we're going to do with it. We're going to plug it in. I'm going to pick 2.5, and I'm going to pick 4. So I'm picking numbers that live in these intervals. So again, you can pick, it's coming back a little. So you can pick whatever number you'd like. Again, you don't have to pick the same number as me. That's not the game we're playing. Alright, so these are my trial values. So I'm going to plug in 0. And I like to plug it in here because typically it's a little bit easier. So 0 minus 3 is negative 3. And then if I plug in 0, 0 minus 2 is negative 2. Negative 3 times negative 2 gives me 6. And do you see how we want that to be less than or equal to 0? Right, because of the sign right here. Is it less than or equal to 0? No. So this gives me a false statement. That means this region is not going to be where my solutions live. So let's plug in 2.5 now. If I do 2.5 minus 3, I get negative 0.5. If I do 2.5 minus 2, I get a positive 0.5. And I'm running out of room in that box, but just pretend this all is in here. And I'm going to see if it's less than or equal to 0. I think we can tell by the signs that it's going to be less than, right? I don't even know why I did that on my calculator. That didn't need to happen. Okay, so negative 0.25. Is that less than or equal to 0? Yeah, so this is true. So I have solutions that live in that little interval, that window. Let's look at the last window. We're going to plug in 4. So 4 minus 3 is 1. 4 minus 2 is 2. And again, we want that to be less than or equal to 0. 1 times 2 is 2. Is 2 less than or equal to 0? False. So my answers do not live here.
Have the middle one that is just the outside.
Typically, yeah. I hate saying always in math because it makes me nervous because there's always like, but what if it was like sine or cosine, right? Like what if we threw in some weird situation? 99.9% of the time, it's either going to be the middle or the extremes is what I call it. So if the middle works, the extremes are not. Now, to graph my solution, close circle, because they're mimicking the fact that it can be equal to, and then shaded in between, because that's where my answers live. Then you're going to write out your answer. And Catherine, this is another spot where you do have to write it out in this notation. So it might just be better to like stick with it. Okay, so you're going to need both of these answers. So when I look at your paper, I'm going to want to see a graphical answer, because this is showing me where your solutions live, but then also an interval notation. 2.
Just
For no. I don't know however many are on the board. We just move on. Okay. Next!
we just do one more and then
No, we need to practice.
Well, we can practice on the next one and see if we're feeling okay with it.
No, there are two more that are very different. If I thought we could just do one more, I would. Trust me.
That's supposed to get harder.
A little bit, but not much.
Stop. Okay.
This one's actually already factored, so I mean, in some ways, I think it's easier. Okay, sorry here. Some of the problems you encounter will already be factored. So do you see how this one's already factored for you? That's kind of nice, right?
Sure.
Okay, let's think about our. Sure, sounds great. Do I need to move all my terms to one side? Nope, already happened. Do I need a factor? Nope. So step 1 and 2 have been done for me. Step 3, I want to find my critical values and plot them on my number line. What would make this 0? 0, right? If it was 0. What would make this set of parentheses 0? 1. What would make this set of parentheses 0? 3. So my critical values are 0, 1, and 3. So I'm going to put those on my number line, 0, 1, 3. Now, do you see how this time it's just less than? So I'm not going to include 0, 1, and 3 in anything. So let's think about our intervals. We should actually have 4 intervals, so give me an extra section to this. It doesn't quite have enough. All right, so we've got negative infinity to 0, not including 0. We've got 0 to 1. We've got 1 to 3. And then we've got 3 to infinity. Okay? So these are our different little windows of area. So now we're going to pick numbers that we can plug in. Again, it doesn't matter what number you pick. I'm going to pick negative 1. I'm going to pick 0.5. I'm going to pick 2. And I'm going to pick 4. Why make your life tough? Right? You could pick different numbers. You could pick pi to plug in.
Okay.
But you don't need to. Right? Why would you do that? I don't know. All right. Here we go. I'm going to plug this one in on my calculator instead of doing as much in my head as I was. So let's see. If I plug in negative 1, I get negative 1. And then I've got negative 1 minus 1, and it's being squared. And then I've got negative 1 minus 3. So do you see how I just typed it all in exactly as I see it? Yep. Thank you. You're outside. You can come grab your stuff. And you get 16. Yay, 16. Okay, and we want that to be less than 0. Oh, is it? Oh, that's unfortunate. Okay, so that's false. All right. I'm going to do the same thing, except I'm going to plug in 0.5 this time. So 0.5, parentheses, 0.5 minus 1. Close it, square it. Parentheses, 0.5 minus 3. So do you see how I'm just typing it in? Okay, and then I hit enter and I get, ooh, an ugly decimal. But is that ugly decimal less than 0?
Yes.
Sure is. True. Now, here's another thing you can do. I think we talked about this before.
Oh, you single it out. You're not distributing.
I'm going to reach up and grab one of the previous ones. You see how I can do that? It's like a copy and paste feature. So I'm going to arrow up and grab it. And then I'm going to type in a 2. And I'm going to delete the decimal. Because that makes my life easier. I just reached up and grabbed it because I was lazy. And I'm just deleting decimals and typing in 2s. Is what I'm doing. let's see, delete. You can just type it in from scratch if you think, well, that probably just took me extra time. Ooh, I got -2. Is -2 less than 0? Yeah. Alright. Alright, and now we're going to plug in 4. So again, I'm just going to reach up and grab. And I'm going to put 4. And another 4. And another 4. So again, you just arrow up and you hit enter, and that grabs your previous line of work. So that's what I'm doing there. So you're going up and grabbing the previous line of work so that way you can reuse it. I get 36.
False.
Is 36 less than 0? No, that's unfortunate. Okay. So, this can't be a solution because it can't be equal to 0. So there's an open circle. This can't be a solution because it can't be equal to 0. However, there are solutions that live in the middle. This also can't be a solution, but what lives in the middle can. So this is what our solution ends up being in terms of like graphically looking at a picture. So, my solutions go from 0 to 1 in union with 1 to 3. So this is how you write it out in interval notation. Remember, we call this interval notation. So that's how you write your answer in interval notation, and then you also need your answer graphed. So you need both forms. It's kind of two different forms of the same answer. So more of a visual form, and then also having it written out kind of algebraically. Does that make sense?
Yes.
Yeah, go ahead.
The two else, well, if it's all horizontal to, you need to put the middle in.
If it
Like the middle circle.
was filled in, you could go 0 to 3. Yeah. Good question. All right, last one. You'll see why this one was a little bit separate from the other ones and why we do need to do one more.
Not the fractions.
Fractions. Here we go.
No way.
All right. So the question becomes, how do we find critical values for a problem like this? So our critical values are what make the numerator and denominator 0. Let me zoom out just a little. Alright, so before I can think about what makes the numerator and denominator 0, I need everything to be on the same side. Just like, remember the original set of directions we had? Step 1, get everything on the same side. So step 1, I'm going to subtract over 1 to the other side. So I get 1 plus x over 1 minus x minus 1 is greater than or equal to 0. When we've had problems like this before, do we typically like the fractions to stay separate, or do we kind of want to package it into one little package? Package it up. So let's put this over 1, and let's get a common denominator. So I'm going to multiply by 1 minus x on top and bottom. So again, I'm trying to get a common denominator so I can just have one fraction on the left. Okay, I'm running out of space, so I'm going to come up here. So I've got 1 plus x minus 1 plus x. Look how I got this. Let me walk over here. So I've got 1 plus x minus 1 plus x, because look at this. We've got a negative times a negative. That's where I'm getting the positive x. Do you follow my work there?
Yep.
Sure? Don't just say sure like that, do you?
Kind of.
Kind of. No? No is an okay answer. Alright, let's look. Let's look. So we had our first fraction here. We moved the 1 over to the other side, and we wanted a common denominator so we could condense it down into one fraction. In order to get a common denominator, we need to multiply so it has the same thing in the bottom. Remember that you kind of carry through with your denominator. So there's my 1 minus x. And then you actually combine the numerator component. So I've got 1 plus x minus 1 And then negative 1 times negative x is a positive x.
Okay, I get it now.
Good?
I thought you were, I don't know.
Yeah.
Some not that.
Not bad. That's fine.
Much simpler now.
Okay, let's continue to simplify.
No.
The plus 1 and minus 1 cancel. So I've got 2x, and then I've got 1 minus x. And then my other symbol kind of fell away, so let's put that back in. This is what we want going on. We want 2x over 1 minus x is greater than or equal to 0. It's not my answer, I shouldn't have probably boxed it in, but this is what I get once I condense it. What value of x would make your numerator 0? When x is what? 0. So our numerator would be 0 when x is 0. So 0 is one of my critical values. When would my denominator be 0?
1.
When x equals 1. Agreed. Because 1 minus 1, 0. Okay, so these are my two critical values. So go to your number line. 0 and 1 are the critical values on your number line. So what are my intervals? Negative infinity to 0, 0 to 1, 1 to, oh, what did I do? I should be doing something different. I made a mistake. Not a parenthesis, but a bracket. Yep, I need a bracket because can I include that? Yes. Now, be careful because there's one I can't include. The numerator can be 0. Can the denominator? No. So this one is going to stay a parenthesis. I know that it says it can be equal to 0, but because this is when it would be undefined, that's still going to stay a parenthesis. And then 1 all the way up to positive infinity. So 0 is okay because we can have 0 in the numerator. 0 divided by something is 0. That's fine. We can't have 0 in the denominator. That's why the 1 gets a parenthesis. Okay, let's start plugging stuff in. I'm going to plug in, let's see, negative 1, 1/2, and 2. Again, you can plug in different numbers for me. Doesn't matter. Here we go. Again, you know that I kind of ignore this, and I'm just plugging in a trial value here, is what I call it, trial value, and then this is true or false to me. That's kind of how I think through them. All right, let's start with negative 1, and I'm going to plug in here because it's going to be easier. If I plug in negative 1, I'm going to get negative 2 over 1 minus negative 1. So 1 minus negative 1 is really 1 plus 1, which is 2. Negative 2 divided by 2 is negative 1. Is negative 1 greater than or equal to 0? No. False. All right. Half of 2 is 1. 1 minus 1/2 is 1/2. And the question is that greater than or equal to 0? If I have one candy bar and I divide it in half, how many pieces do I have? 2. Is 2 greater than or equal to 0? Yes. So that is true. And now let's plug in 2. 2 times 2 is 4. And then 1 minus 2 is negative 1. Question is that greater than or equal to 0? Is negative 4 greater than or equal to 0? False. So the middle is correct. Now be careful because 0 can be included, but because 1 would make your denominator undefined, 1 can't be. So you've got to be careful there. So when I draw this out, I would say 0, 1, and we get a parenthesis. Good? So those are tricky. That's why we needed to do kind of a little bit extra there. All right, this is assignment number 12 for us. I'm not going to have you do a ton of problems because, again, I'd rather have you do a couple well and make sure you know what you're doing and kind of cement what we did in class than do a ton of them and not do them quite as well. Page 80 in your book, numbers 35, 39 to 41, and 57 to 58. That's not a ton of problems. But it's enough, hopefully, that we can get some good practice in and ask questions if we have them. You have lots of time right now, so go ahead and get started.
I use the bathroom and I need to get a pass from the counselor's office for going outside.